Hello, and welcome to Lessons Learned from Online Co-Design, exploring reflections of connected participatory strategies for computing-based data science curricular design. My name is Amanda Brainey, and I am a postdoctoral research scholar at the Penn Center for Learning Analytics at the University of Pennsylvania. I'm excited to spend the next few minutes introducing you to some elements of the Coding Like a Data Miner grant and research project that was founded by our NSF principal investigator, Justice Walker from the University of Texas at El Paso, and with the support and leadership of our team of student researchers, Michael Johnson from the University of North Texas, as well as Alan Barrera and Alex Aqua, also from UTEP. A big shout out to our broader team of collaborators is also shared at the end of this presentation. So our research is founded in computer and data science education, and specifically the development of a computing-based data science curriculum that we have titled Coding Like a Data Miner. And this emerged as our focus, given the emerging and increasingly recognized value of computer science skills, such as programming, not just for success in STEM careers, though certainly in those contexts also, but also across broader social and civic contexts that we will encounter across our lives and careers. Data is all around us, collected on us as individuals, on the groups and communities that impact us, and in many cases, it shapes the information that we access on a daily basis. So given this increasing interdisciplinarity and the ubiquity of these fields, it's really essential to start to empower youth to develop their own computer science consciousnesses that can allow them to ask and answer important and relevant questions for themselves using data, to critically analyze process and outcomes, and to embrace the iterative complexity of these data science processes. For the curriculum we developed as a part of this project, which we call Coding Like a Data Miner, we designed learning experiences in which students access online social media sources, in this case, Twitter or X. The affordances of this being that social media sources might have inherent interest to learners who likely use social media themselves, that social media data sources can be quite vast and accessible for students to curate and explore their own personally and culturally relevant data sets, and that such data sources often reflect the diversity of perspectives within and across online communities. Certainly a worthy area of exploration. And putting all this together led us to the concept of sandbox data science, the idea being that social media data sources are open-ended spaces where students can play, explore, tinker with ideas in authentic and complex ways. There are several theoretical, pedagogical, and design-based tenets that we draw on to conceptualize the idea of sandbox data science. The first is the idea of cultural relevance as a design principle guiding the creation of our curriculum. So this manifests throughout our design framing, but the one thing I'll highlight here is the flexibility that learners have to choose their research topics and subsequently mine and analyze their own unique social media data sources that align with any topic they choose, particularly those that might connect to their personal interests, any important socio-scientific issues in the moment, such as in current events, and connect to culturally relevant issues that they find important and valuable. Another thing I'll highlight is an emphasis on computational literacy as a learning goal in Coding Like a Data Miner, where students are repeatedly guided through the steps of engaging in authentic, sometimes complex, but ultimately rewarding data science processes that include things like sourcing, cleaning, analyzing, and visualizing data, with fewer scaffolds and more opportunities for students' free inquiry as they move through each of these 4 cycles shown here. Ultimately, our goal with this project, the design and framing, is to disrupt some of the participation disparities that continue to persist in these fields. Ultimately, it's through the application of this design where a student like this one from our last implementation of Coding Like a Data Miner might be able to ask and explore a question like this: which soccer player is the greatest of all time? By identifying code he would need to mine the data set of tweets that contain opinions on each player, then repeatedly return to cleaning and processing to prepare that data for the visualization here that shows a narrow winner. Through this inquiry, he was able to build on personally relevant computational literacy by addressing targeted challenges as they emerged throughout his tailored project. So there is a third tenet that's essential to our project that I've held off on discussing until now, because it really gets at the heart of this work and the focus of this presentation more specifically. And that is the intentional integration of participatory and collaborative design methods, or co-design, to ensure that teachers and students who might use or benefit from a curriculum like Coding Like a Data Miner are, again, influential and active participants in the curriculum's design. So our focus on these co-design practices also supports culturally relevant practices and computational literacy development, as our co-design collaborators remixed and created curricula with us that are better aligned with their needs. Ultimately, we hope enhancing the learning experience in ways that we felt as researchers we could not on our own. What we found in a review of existing research on the literature around computer science and data science curricular design is that there's precedent research that leverages participatory design with students and educators in computer science, and that there is utility in this process for supporting culturally relevant pedagogy, but also that there's still a need for more examples of participatory co-design in this context, in which participants engage more actively as designers, as opposed to more passive roles like offering feedback. We also found that many examples of participatory design apply more unplugged approaches, which misses out on a really valuable entry point for using online tools and spaces that could increase access, support collaboration, and facilitate personal investment and more active engagement. And so that's where connected learning theories come in. From this perspective, there are clear affordances for virtual co-design opportunities. Connected learning theories applied to computer science education have informed designs that have enabled personal investment in technically sophisticated artifact production around curriculum, through learning arrangement designs that encourage social interactions and community building, through extension activities that support ongoing engagement. So what we hope to contribute to this conversation is a discussion of our virtual co-design sessions for Coding Like a Data Miner, including the particular benefits and points of tension that emerge when leveraging the affordances of these online tools and spaces like Zoom to support virtual co-design for sandbox data science. Here is where activities may end up being more diverse and open-ended through sandbox data science, and more exploration and participation might be wide-ranging, personalized, and multimodal. So we wanted to see what co-design for a curriculum like this looks like. What we hope is that this discussion might serve as a possible resource for future efforts like ours that might engage in online curricular development using participatory approaches, particularly those that might involve learning designs that are media-laden and open-ended. Our research question here asks, what benefits and points of tension exist when building diverse online communities to support curricular co-design? So a little bit about our virtual co-design workshops for the Coding Like a Data Miner curriculum. We developed and hosted 2 week-long online co-design sessions in June of 2022. Session 1 included 5 youth and 3 adult educators, and session 2 included 8 youth and 3 adult educators, all from the El Paso region, where our grant was focused to provide targeted design and support. So the researchers, that's us, served as facilitators, while educators and youth focused on gaining understanding of some of the initial drafts that we'd prepared for Coding Like a Data Miner, and then providing feedback in session 1, followed by greater emphasis moving forward on reworking the materials and designing new elements, particularly in workshop 2. So overviews, instructions, and summative discussions were carried out in the primary Zoom room, usually at the beginning of the day. And then smaller, more intimate Zoom breakouts allowed the co-designers to connect, review, modify, offer small group insights and suggestions for the curriculum. Some activities were assigned to homogenous groups, such as the teachers mapping curriculum artifacts to specific computer science standards, while other activities were completed by teacher and youth interdisciplinary groups, such as creating and pitching the new final project design ideas. So some of the key questions that we posed to co-designers were things like, what were the most important observations in relation to instructional priorities? What were the curriculum's observable strengths? What could be improved? What strategies would allow us to make these improvements? And things like that. So we used the reflections from ourselves as researchers collected during and just after each workshop as the primary data sources in this study. Reflections were based on our collective observations during co-design implementations, which we then corroborated during research group discussions that took place during data processing and analysis. We also used transcripts from the participants' interviews and artifacts from the workshop as secondary sources to help sort of contextualize these summative ideas that I'll share in a moment. And finally, we further synthesized the results in this work when consulting with other researchers who were interested in understanding these co-design strategies, which ultimately led to our categorization of the three main findings or topics that I'll discuss. So logistical, pedagogical, and social considerations for virtual co-design in our context. We used the reflections from ourselves. For the results of this work, we first noticed that logistical and technical structure of the virtual experience shaped participant engagement and contributions, and that this resulted in some unique benefits and tensions. We were happy to learn that hosting the experiences online made them accessible for participants who might otherwise not have been able to travel or contribute to co-design. Specific digital features were also found useful for supporting practicality and versatility in the implementation of co-design. Things like screen sharing using Zoom, file sharing using Google Drive, and group workspaces like Miro boards, all of which helped us facilitate resource sharing and interpersonal interactions. And so participants were able to engage in collaboration, discussions, and build diverse, large, and small group relationships. We noticed that these affordances happened across content areas in the co-design and across activities, including moments when participants revised existing material and when they were developing new ideas. So in discussions with participants, we found these logistical tools helped them to develop interpersonal relationships, share ideas openly. And you can see this in some of the quotes from the educator and youth participants here. So while these logistical tools work well in some cases, tools for sharing and showcasing Python code, for example, as part of the Coding Like a Data Miner curriculum, were at times either too simple or in other cases too technically complex for diverse stakeholders. And so this we found sometimes limited some of the more robust engagement in and redesign of the material in some cases. This occasionally resulted in extra time spent supporting tool literacy, where we would have hoped that time could have been spent on more active curriculum co-design. So as much as virtual collaboration offers accessibility, it also necessitates access to quiet spaces with functioning Wi-Fi, with good audio, good camera, microphone, resources that are not always consistently available to participants attending across locations. And so this sometimes limited different people's contributions at certain points. For the pedagogical considerations, when designing the structure and pedagogy of the participatory experiences, attention was paid to the flow and order of activities across days 1 to 5, the organization of daily activities, and the makeup of stakeholder groups for those. So examples here for the session 1 workshop. Day 1 began with guided introductions to the existing Coding Like a Data Miner materials, leading into participants' more active development of their final summative presentations of all of the different design goals during a final showcase on day 5. This structure was intended to provide kind of a soft but active onboarding of participants and build their confidence and understanding of the curricular elements that we had in mind before then situating them as experts of their own co-design and their recommendations at the end of each day. So this involved daily 2 rounds of structured co-design activities every day, followed by a whole group debrief of every day's experiences, a whole group discussion in the main Zoom room, and then ending in some prep time for their summative day 5 showcase. And this was intended to target their engagement to specific but necessary elements, things like refining worksheets that we made, reworking slide materials, and support the inclusion of these iterative developments in their summative presentations also. And as I mentioned previously, certain activities were also targeted to teachers or youth based on their areas of expertise. So tensions revolved around the time-consuming nature of some of the high-level engagement moments, such as when teachers mapped out the curriculum to existing CS standards, like here. Also, while we received positive feedback on the introductory events that were designed to acquaint participants with materials, some expressed that they still found this sort of daunting. So solutions to this could be more scaffolding at the beginning of a workshop or more support around any particularly complex tasks, particularly those who use things like Python code, or more repeated scaffolding maybe throughout the workshop. So things to consider. Finally, for social considerations, we found that these dynamics played a key role in the enactment of the sessions, at least based on participants' discussions. They highlighted the development of the interpersonal relationships that not only enhanced their productivity through different kinds of task management and execution of practical tasks, But it also helped them foster these feelings that they described to us of the legitimacy, the efficacy, and sort of this freedom to engage and explore these ideas openly and independently. So relationships within these co-design sessions were valuable, not just for group productivity, but for validating each other's contributions when groups would share out with each other. You can see from these quotes from one of our educators and one of our youth participants how they emphasized the value of these affordances, and they talked about them often. But on the other hand, the perceived authority or knowledge differences between teachers and youth or other dynamics sometimes impacted the session dynamics at times. So teachers sometimes described feeling like they were dominating the mixed cohort conversations, and that students sometimes had these sort of confidence issues. And often these dynamics were negotiated, but we noticed that they sometimes resulted in sort of slow starts for different rooms. These tensions were alleviated when groups were able to come to consensus on next steps, such as what the experience of the youth here is describing. So to sum up these initial findings that we noticed when enacting the design strategies for Sandbox data science with coding like a data miner, we found there's real value of collaborative design and online platforms in creating inclusive and culturally relevant curriculum. By involving learners and educators as co-designers, the final and subsequent versions of the course are better tailored to their needs and interests, resulting in more culturally relevant learning experiences that we hope can equip learners with computational literacy. Since the completion of these co-design workshops, the materials that were designed and reworked by participants were presented to educators in the El Paso region, who further tailored courses to their specific contexts. And we also implemented an all virtual version of Coding Like a Data Miner with online students from across the United States, some of whom created the awesome project examples I shared earlier. Finally, we're in the middle of another implementation that's partnering with local stakeholder agencies, an energy company and a healthcare company, to further embed Coding Like a Data Miner in local, cultural, and sociopolitical contexts for students. What we hope to do moving forward is to contribute to co-design for curricula like these by integrating some of these reflections and lessons learned into a more formal practice framework in the future. We'd love to discuss this with you at the virtual meeting session this week. Practically, we also hope that these insights might support future online curriculum development that uses these participatory approaches. If you want to reach out and talk more, you can contact us using the contact information on our website. So access the QR code that's posted here. So this is for the Coding Like a Data Miner project, where you can actually find some of the curriculum that was developed as a result of these co-design sessions as well. And last but not least, many thanks are due to our research partners and collaborators shown here, as well as to the National Science Foundation for funding this endeavor. Thank you for your time.